Welcome back. In this video I'll be solving with problem 2429, minimize XOR. Okay, given two positive integers nums1 and nums2, find the positive integer x such that x has the same number of set bits as nums2 and the value x XOR nums1 is minimal. Note that XOR is the bitwise XOR operation, return the integer x in this case. The number of set bits of integer is the number of ones in the binary representation. So what we have to do first, let's find x as the number of set bits, or let's call it just bits. Bits is equal to 0 and for it is num. So for num2 or while, so let's call it current is equal to num2 while current is not equal 0, current bits bits is current modulo 2 plus something like this, and current is current divided by 2, but integer division. So okay, now we have number of bits that are set. Now we need to find x that has bits excuse me. So now we have to find x that XORed with num1 is minimal. So how do we do that? We have to check what is the position of highest number of highest bit in num1 to kill it with 1 with a set bit. So I know I have this bit, so I will have some kind of let's say array that will track so the same thing but for nums1. Okay, and now we'll have to track not bits but power is equal to 0. That will tell me which power of 2 we are talking about. So wait, for other need power, do I need array for that? I actually do not need, or have to know what is the Yeah, let's get the array, so that will be more straightforward. So sorry about that. Array append, so current module 2, it will be 1 0 whatever. Okay, and I have the number, and that's a bits 2 is equal to 0. Yeah, I don't have to do this. I can just sum it. So I can sum it up. So this is num1. I want to have like left to right pass or right to left pass, and then let's do it like this. So I have bits, and now I want to go and kill them. So for in range len of array, or array is reversed array, and len of array if r of I is equal to 1, if bits is greater than 0, r of I is equal to 0, and bits is minus equal 1. If bits is equal to 0, I just break. And I need to have answer is equal to 0 power of the array, and so power is also equal to n. And minus 1. So array is 1, bits array 0, and answer plus equal to the power minus I. if bits is equal to 0, return answer. Return answer, else I have to go here. R1 of y is 0, or let's reverse that, I don't give a fuck. Whoa, sorry. So array is reversed array. I'm a bit nasty, sorry about that. So array is reversed array, answer and array. Okay, array. And this is this one. And what do we do? So else array is reversed array, and I try to go to the lowest one, so so I already killed all ones, so I have zeros. Either I killed all of them, how will I know? Let me think about how will I know that I killed them. Yeah, I need R1. My bad. So this is killed. Then R1 is 0. Okay. This gets too convoluted for some reason. So that's if bit is if I spend all the bits. If I haven't spent all the bits, then I need to reverse the lowest numbers I can. Okay, then I can do, there is no if, because I return. So R1 is reversed R1, and I have R. So for I in range n, for I in range n, if R of I is equal to R1 of I, then I haven't changed it, so I can bits minus equal 1 and do the answer plus equal to the ith, and if bits is equal to 0, return. Okay. Where is that? bits minus equal. Okay. Okay. Reversed. So R dot then reverse will do the job. Don't really have to do it like this, so I have let's come on. Maybe I can do this. So I'll have original is equal to array. I for I in array. I don't need power. I can do it range n, but I will go from the last one, so from the n minus 1 by minus 1. And it will go to the power of I, yeah. So no need for this. R R of I is equal 1, okay. So I have original for I in range n if original of I is equal to let's see, I can go for the next one. This should be okay. One and 12. This one has too many bits, so for I in range. Okay, I have still some left. That means that I had to go for so while bits is not equal 0, I'll go and I'll go ons plus equal. So here I have times I times n plus this one, so 2 to the n n plus I is equal to 0, I is equal 1. Okay, and then I return answer. Okay, this went a bit far, but I think I got it. Submit, and it works. Great. Not sure if we could make it a bit easier, but I think it's kind of straightforward. So this part is just getting number of bits. So let's maybe write it down. Number of set bits. Binary representation. And here on we are trying to remove most significant bits, yeah. And here is add least significant bits, and that's it as possible. So yeah, time and space complexity for this one. Well, I suppose it's time complexity of n has to be, but space complexity also of n. Yeah. Of n for both. Or log. It's log because we are always doing a while divided by 2, so. But isn't it like of n for I and r? Yeah, array, but array is binary. It's log number of elements, so. But this is, these are numbers, so there's no, n means nothing, so log of num1, num2, yeah. Yeah. Log and memory of the memories of a log. Yeah, my bad. Log of n plus log. Yeah, I was a bit not thinking for this one. So, and the same thing here. So yeah. You can stop if you're interested in the code. So here's this part, and finally this part. I hope everything was clear. Thank you for following in this one, and see you in the next one.